requirement on the personnel skills. Okay. Okay. Then, okay, that's it first. That's why we need something that can automatically assign IP address to the terminals, centrally manage the host configuration, and because there's a centralized management, it can avoid IP address conflict. We let machine to do it. It can be more accurate. Okay, less error. Okay. Then, so this is DHCP. Okay, the full name is a Dynamic Host Configuration Protocol. So it's using UDP port 67 on the server side, port 68 on the client side. Okay. Then, the DHCP server, okay, is here. So it provides high efficiency. Okay, anyone want to connect to the network, okay, the device will just automatically get the DHCP IP address from the DHCP server. You do not need to request from the receptionist, what IP address should I use? You don't need to ask any administrator, please help me to configure IP, no need. Okay, improve the efficiency, strong flexibility. The IP address can be reassigned to another terminal. If the previous terminal already disconnected, the lease time is expired. Okay? It can be reassigned to another terminal. So improve the IP address utilization, easy management. Okay? You can keep track. This IP address assigned to which devices, of course, based on the MAC address. Okay? You can keep track. You still have how many IP address available. It's not being assigned yet. Okay? Then, when the IP address pool is exhaust, you also can check, oh, it's already exhaust, so you can do something. Okay. Okay. Then the DHCP, okay, then any kind of device can become DHCP client, including this IP phone maybe, or the network printer, and even network devices. Firewall, router, switches, AP, AC, okay? They also can become DHCP client. But usually we set static IP, but you have the options to let the network devices to use DHCP to get IP addresses. Okay, you can do so. Then the DHCP server, it can be any devices that can configure DHCP service. It can be a dedicated server, Windows server, Linux server. It can be a firewall, it can be a router, it can be a switch. Okay, it can be a network devices or a dedicated server. Okay, so it's just a service. Okay, then, okay, DHCP working mechanism. Okay, how it works. Basically, the client, usually the client and the server is in the same broadcast network, layer 2. Okay, so that because the client at the beginning, it doesn't have any IP address. It cannot send a packet to another domain, another network. Cannot do routing. Cannot. Okay, so you only can discover the DHCP server in the local network using broadcast frame, broadcast packet. Okay, so as we learned from the IA level, broadcast packet only can be flooded within the local network only, the local VLAN only. So we need to make sure that the DHCP server is reachable within the local network. So the DHCP server can send a offer message to the client reply with a request, then the server reply with a acknowledge. Discover, offer, request, acknowledge. BORA, the very standard. Okay, we can say this is a 4-way handshake. Okay, because we got 4 packets, 4-way handshake. A very standard process for a client to get IP address from DHCP server. Then this is not just illustration inside the real devices. The actual devices. Yes, if you can use the Wireshark to capture the process, you will really see these 4 packets. Okay, in this sequence, DORA. Okay, then yeah, else here. Okay, so inside the offer is actually the IP address and other details. Okay, the server want to offer to client. Okay, okay, okay. Okay, so these are some the structure. Okay, structure of the DHCP message. Okay, so there are so many things here. Okay, is it important or not? Not really. Okay, not important right now. Okay, let's go through. Okay, option field. Options. Okay, options. Oh no, it's here. Okay, here. Okay, this thing. This is important. Okay, because it can be very flexible. Okay, very flexible. Okay, this is why we can use the DHCP server to assign IP address. Okay, assign IP address is the very basic features of the DHCP, but we can use the options. We can, because it's variable. Depends on what is the options we insert. Okay, DHCP can do more things for us. Okay. Okay, so there are some options field. We say that, okay, I think these are default will have all these things. Let's say subnet mask information, router, request IP, list type, message type. All these are the basic. Okay. Then, yeah, type TLV. Okay. That's how we already see that we have a DHCP discover packet, offer, request, acknowledge. Then there is something called decline, not acknowledge, release, or inform, all these things here. Okay. Okay, then yes. The options we are looking at is this user-defined options. Okay, user-defined option. Let's say option 82 is for the DHCP relay agent. Okay, relay agent. For this one, I think we don't really need to specify this. But this one here, option 43. Is it familiar for you? For what purpose? Is it that vendor specific? What is this? Yes, it's the WLC or WAC. AC, same thing, okay? It's the AC IP address. Okay. While you are using DHCP server to assign IP address to the AP, which means AP works like a DHCP client. It requests for IP address. DHCP server also assign the information we call option 43. What is this option 43? Inside this option 43, inside this field, it will tell what is the IP address of the AC. So that client AP can send a unicast packet to discover the AC. Okay. Option 43. Okay. So when it comes to Huawei AC class fit AP solution, we use AC to manage Huawei fit AP. Then we need to configure option 43. Not need that. We can configure option 43. Okay, when the AC and the fit AP is in 2 different VLAN. We need the option 43 if you want to use the DHCP method. Okay. So why we say that this is the vendor specific? Because option 43 is only for Huawei. Yeah. The DHCP server, it can be another device. Maybe it's the firewall for another vendor. Just works as a DHCP server. It can be a Windows server, work as a DHCP server. Okay. So you just tell your, let's say, Windows server, you have Huawei AP. Okay, you are using Huawei AC, Huawei Fit AP. Then you are using the DHCP server is a Windows server. So you just tell the Windows server, you just set the Windows server. When you assign IP address to AP, you also give the option 43 to the AP. Maybe the Windows server itself, it doesn't understand. This option 43 means what? Okay, the server don't need to know. You just tell the server, you give it option 43. Then you put the information. It's just a string. Okay, the server will just treat it's just a string. Option 43, that's the information. Looks like an IP address. Okay, it just send this information to the feed AP. So all the Huawei feed AP, when they receive this information, option 43, automatically they know that, oh, this is the AC IP address. Okay, this is the Huawei feed AP will behave. Okay, when they see the option 43 information, they will start to look for the AC. Okay, so this for Huawei feed AP only. Okay, then different vendor use different option. Okay, different vendor also have the same solution. Okay, one AC or WLC, WAC to manage multiple AP. I don't know, Aruba using what option? Do you know? Anyone have experience? Okay, in Aruba? Don't know. Okay, how about Fortinet? Fortinet, do Fortinet have any AC device? WAC device, WLC device, Fortinet? Yeah, correct. Okay, they use the FortiGate itself as the AC. Okay, so what is the option? They also have the option number to tell the FortiAP what is the IP address of the FortiGate. What is it already? Okay, let's have a search. I see this before. That's not common to be used. I mean, 40 AP, not common. So I forgot, let's say, but there's such a thing. Okay, it's not 43. 40 AP option. One, 3, 8. Yes. Okay. Option 138. Okay. Okay. When you assign the option 138 for DHCP server, you assign IP address to the 40 AP. 40 AP see the option 138. Okay. Automatically, it will know that, oh, this is the 40 gig IP address. So they will send unicast packet to discover the 40 gig. To get import into the FortiGate. So from FortiGate, then you can see this AP. Then you can manage the 40 AP. Okay, so yeah, so vendor specific. Okay, different vendor using different number. Okay. Okay, okay, next. Okay, so again, the same thing example. So this is the AC, this is the AP, Huawei AP, Huawei AC. Then when the switch works as a gateway, okay, also as a DHCP server, assign IP address to the AP, and also at the same time using option 43 to tell the AP that this is the IP address of the AC, so that the AP can use a unicast method, okay, unicast to discover the AC. Because AP and AC is in two different VLAN, you need to do routing. That's it. Okay. But even though, even when the AC and the AP is inside the same VLAN, you also can apply option 43. Not wrong, okay? You can do so. Okay. Okay, that's it first. So yeah, then we can see this cat web, this term cat web. AC and the feed AP will form a cat web tunnel. Okay, this is how the AC can manage the feed AP. Okay, cat web. Okay, then back to the basic. Okay, DHCP assign IP address, so there will be a lease time. Okay, by default for Huawei device is 24 hours. Okay, if you're using the Huawei network devices to assign IP addresses to the terminal, by default 24 hours. Okay, maybe other vendors also apply the same practice. Okay. Okay, that's it. So that when the lease time reaches 50% pass away, okay, then the terminal will send a unicast request to ask for lease renewal. Okay, if there's no response from the DHCP server, then it will wait until 87.5% pass away already, then broadcast the request message. That's how it's unicast. Not so urgent yet. Now it's broadcast, very urgent, because the lease time going to expire. But then there's still no response. Then after the lease expired, the client will just release the IP address, and then restart the DORA process, okay, to get the new IP address. Okay, then there's a question: why is the same IP address assigned to a terminal as at each time? MAC table. MAC table is a switch. MAC table. The record. Yes, correct. Because of the record. So client reuse of an IP address. Okay, so what you do actually is, this is the behavior of the terminal. Okay. When the client reconnect to the network, let's say yesterday you already connect to our Wi-Fi. Now then you go back home. Then today you reconnect. Okay, the terminal will automatically request to reuse the IP you are using yesterday. You try to do so. Okay, then okay, what I do, it will broadcast a DHCP request. See that? It doesn't send discover, it sends request. It's trying to ask the DHCP server, can I reuse the same IP address I used previously? Can I do so? So if the server okay, then okay. Okay, server will reply with the acknowledge. Okay, you can continue to use. Okay, but if the server say cannot, let's discover again. Okay, maybe then server will just reassign another IP. Fine. Okay, for the end user point of view, if they don't care about what IP address they're getting, so it's totally fine. All these are automated. Okay. No need. Okay. Okay, no need. If the server agree that the client can reuse the same IP. If not agree, then it will reject. Okay, then the client will just redo the DORA. DHCP do not agree you to reuse. So you just reapply again a new IP. Okay, yeah. Okay, so this is how the DHCP server assign IP address. Okay, the flow chart. So first, let's say we start from the client is clean. Okay, it's just the first time connect to the network, send the DHCP server, DHCP discover to the server. So server first, because you know what is the MAC address of the terminal, you will try to look for, is there any IP address is reserved or bind to this MAC address? Okay, static bound, call this reserved. Okay, is there any IP address reserved or bind to this MAC address of the client? If yes, that's assigned. If no, use IP address. Is there any IP address previously assigned to this client or not? Oh, if yes, then that's reassign the same. Okay, that's assigned the same. Yeah, so this is the IP address requested in the DHCP discover sent by client.